Hi guys, the next section, part of the section here is factorial notation. So n factorial, which I hope you've seen before, is n exclamation point, where you take that value and you multiply by every single integer that comes before it all the way down to 1. So I shouldn't have said integer, I probably should have said natural number, where n is a positive integer. Okay, so really quick on the calculator in case for those of you who don't know where this is. So for example, say I wanted to do out, like 8 factorial, I would type 8. And then if you go to math over to probability, it's number 4. And then just hit enter, and that actually does 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 for you. Just for people who might not know where that is, who haven't taken stats yet, I don't know. There is a special case, 0 factorial is equal to 1, and I know you're just dying to see a proof of that, so I, have this for you here. Maybe you're going to fast forward through this part. Don't. All right, so proof of y is 0 factorial 1. If this thing would focus. Okay, so we know based off of the definition of a factorial that x factorial is equal to x times x minus 1, x minus 2, all the way down to 1. So therefore, really, I could rewrite x factorial as x times x minus 1 factorial, correct? Right, just another way to write it. So if I took this equation and actually solved it for quantity x minus 1 factorial, I'd divide both sides by x, and hopefully you agree I would have this. Maybe you don't understand why I'd want to write it that way, but hopefully you at least agree with me. So remember, it's a little proof on 0 factorial. So keep this in mind, we're going to come back to that. We can rewrite 0 factorial as 1 minus 1 factorial, right? Because 1 minus 1 is 0. That's all true. So if we let x equal 1 from above, meaning up here, putting 1 in for x, okay, I would have quantity 1 minus 1 factorial equals 1 factorial over 1. Well, 1 factorial is just 1, and 1 divided by 1 is 1. So that means quantity 1 minus 1 factorial is 1. So by substitution, if we know 0 factorial, we can write that as quantity 1 minus 1 factorial. We just proved that 0 factorial is equal to 1. There are other proofs out there, but there's one for you. So what are you going to do with factorials? So if you had a problem like this, write the first 4 terms of the sequence. So a sub n is equal to n squared over n factorial. Am I in my right color? No, okay. So you are just doing first 4 terms. So a sub 1 is going to be 1 squared divided by 1 factorial, which is 1. A sub 2, that's going to be 2 squared divided by 2 factorial, which is 4 over 2 factorial, which is going to be 2. A sub 3, that's going to be 3 squared over 3 factorial, which ends up being 3 halves. And then a sub 4 is 4 squared over 4 factorial. That simplifies to 2/3. I wasn't going to bore you with the arithmetic, but if you're confused about how I guess I could show how I did that out. I was trying to keep these short because they tend to be long. So 4 squared divided by 4 factorial. So that's going to be 16 divided by 4 times 3 times 2. So we're going to get divided by 48. 24. Yep, I'm doing awesome. This is life with children and teaching math, everybody. And so that's where the 2/3 comes from. All right, so again, can you just evaluate? Here's other examples you will see. So 10 factorial divided by 2 factorial times 8 factorial. So yeah, you can put that into your calculator. But you could also just keep in mind and think about this as 10 times 9 times 8 factorial. 2 factorial is 2, and then 8 factorial is just 8 factorial. Those guys will cancel out. You'll get 90 over 2, which is 45. So, do kind of think about this and how you actually do it. All right, so with n's. Okay, well, n factorial, that's just n factorial. And so n plus 1 factorial, to visualize that, I could write that as n plus 1. And then what comes next in the n plus 1 factorial list? That would be n factorial. So those guys cross out, and you're left with 1 over quantity n plus 1. C. All right, so one like this. Again, if you wanted to write this out, you'd have 2n plus 2 factorial divided by 2n plus 4 times 2n plus 3 times 2n, see I'm just subtracting 1, 2n plus 2 factorial. Why did I stop there? Because I know it's in my numerator. Those guys cancel out. We're left with 1 over 2n plus 4 times quantity 2n plus 3. You do not need to FOIL that. What am I? D. Okay, so that's, remember, that's 2 times n factorial. Don't confuse that with quantity 2n factorial. So those guys cancel out, and you're just left with 2. All right, and the last one for this part of the video. So write the most apparent nth term of the following sequences. All right, so we just give you 0, 3, 8, 15, and what we are looking for is an a sub n equals something equation. All right, so when I'm doing this, I think of this as my a sub 1, my a sub 2, my a sub 3, my a sub 4. And I had to figure out, well, how did I get to all these? And sometimes it takes trial and error. Some people can just see it and be like, oh, I know the answer. So if you think of the, so again, first term, second term, third term, fourth term. Well, when I look from 4 to 15, I'm like, well, hey, 4 squared is 16, and 15 is 1 less than that. 3 squared is 9, 1 less than that is 8. Same thing with 2. 2 squared is 4, 1 less is 3. 1 squared is 1, 1 less is 0. Hey, I think I just found it. N squared minus 1. Again, take some trial and error, but you need to look for patterns, which some people don't enjoy. What about for B? So again, I like to write that this is the first, second, third, fourth. It's just something visual for me. I need to actually see the numbers. So whatever, I'll call this one B sub n because it's part B. So that's what I'm looking for, some equation for the sequence. So I have a 2, 6, 24, a 1, 20. Again, this one might not be so obvious. So, okay, 2, 6, 2 times 3 is 6, 6 times 4 is 24. Oh gosh, does that have anything to do with it? Well, let's write it. So this would be 2 times 3, and this gives me 6 times 4, and then 24 into 120. What are you going to say that is? Do you see any patterns there as I pause? 24 times 5, right? But what do 2, 6, and 24 have to do with anything? Okay, well, let's think about other things. Well, I know that 1 factorial is 1, 2 factorial is 2, 3 factorial, that's 6, 4 factorial is 24, 5 factorial, that's going to be 120. So, oh gosh, okay, well, am I getting onto something here? Am I seeing some sort of a pattern? Well, God, maybe. So let's see, 5 factorial, well, that's the denominator here. 24 is there, 6 is there. Okay, this is the 4th term, but the denominator is 5 factorial. The 3rd term, the denominator is 24, which is 4 factorial. So what I think I just found was the numerator is always 1, and then it's your n plus 1 factorial, because 2 is really 2 factorial, but it's the first term, so I have to add 1. 6 is 3 factorial, but it's the second term, I have to add 1. Again, I don't have just like an equation for you to plug in for these. You have to kind of look at it and see and guess and check sometimes.